In this video, we're going to define the inverse tangent function. Now, let's recall that the tangent function has a domain of all reals except odd integer multiples of pi over 2 and a range of all real numbers. In this image, we have the graph of the tangent function in the viewing window of negative pi over 2 to 5 pi over 2 for the x-axis and negative 1 to 1 for the y-axis. We note that there are vertical asymptotes at x equals plus or minus pi over 2, plus or minus 3 pi over 2, and plus or minus 5 pi over 2. And note that the function fails the horizontal line test and therefore is not 1 to 1. So in order to define the inverse tangent function, we need the tangent to be 1 to 1. So then to define the inverse tangent function, we restrict the domain of the tangent function to be negative pi over 2 to pi over 2, not inclusive. And this segment of the tangent function will be 1 to 1, passes the horizontal line test. Now there are other restrictions that make the tangent function 1 to 1. The restriction that we're using here is the universally accepted restriction. In this image, we have the graph of the tangent function between the vertical asymptotes at x equals negative pi over 2 and x equals pi over 2 with a range of all real numbers. So now that we have a restricted version of the tangent function that is 1 to 1, we can now define the inverse tangent function to be y equals inverse tangent of x if and only if x equals tangent of y. Now remember, we interchange domain and range. So the domain of the inverse tangent function is negative infinity to infinity, and the range is negative pi over 2 less than y less than pi over 2. Now we can take the restricted version of the graph of y equals tangent x and reflect it over the line y equal x in order to obtain the graph of the inverse tangent function. So on this image here in red, we have the graph of y equal tangent x over the restricted domain of negative pi over 2 to pi over 2, not inclusive. And we also have on the same coordinate grid in blue the graph of y equals inverse tangent x. And let's just notice the horizontal asymptotes at y equals plus or minus pi over 2 on the graph of the inverse tangent function. A few notes to make here. There are two ways that we can denote the inverse tangent function. One is to write the name of the function as arctan of x. So we spell that A-R-C-T-A-N. And a second way to write the name of the function is to use a superscript of negative 1 on the name of the tangent function. So in other words, we write the letters T-A-N, then have a superscript of negative 1. And when using the superscript of negative 1, we want to make sure that we do not interpret this as an exponent. So in other words, inverse tangent of x does not equal 1 over tangent of x. And lastly, most calculators have the capability of calculating values for the inverse trigonometric functions, and in most cases, the inverse trigonometric functions are on the same key located above the respective trigonometric function.